Hello and welcome to another episode, albeit slightly behind of schedule, episode of Soul Science. Today we're going to be doing convection currents. So I have 4 jars here. 2 have red food dye in because that's going to have hot water in, and 2 have blue food dye for cold water to go in. So I've just boiled the kettle, so we'll put the hot in the red ones first. Got to get it right to the very brim. Same as it's nearly going to spill off. Okay, and then the cold water goes in the blue ones. Makes sense that, doesn't it? Like that. So I've got cold, hot, hot, cold. Okay? So now the upside down water trick. It's not what we're doing, but it comes in useful for this one. We're going to put the cold on top of the hot and see what happens. And then we're going to do it again the other way around with the hot on top of the cold and see what happens. That should give you an idea about what heat does and convection currents. Do the cold on hot first. Okay, so put the card over the top, there will be a little bit of spill, and then flip it upside down and put it on top of the other one. Okay, there was a fair bit of spill there. Now here's the trick. You've got to try and line the 2 jars perfectly up and pull it out. Okay, and this is what's happening with the hot at the bottom and cold at the top, okay? So the hot is rising and the cold is falling in to take its place. So that's what a convection current is. Heat goes up and the cool comes in its place. So it's like a circle. Trouble with the food dyes is they mix together, so we've got this sort of maroony coloured end up, but you will have the hot at the top and the cold at the bottom. Okay, so this time we're going to put the cold at the bottom and the hot at the top, because the hot will be already at the top, so we'll see what happens, whether it still mixes or in fact hot does actually go to the top or want to go to the top, okay? Or at least one glove to hold the jar with. Okay, so yeah, this shouldn't be that bad. Okay, so a bit spills again, and now we've got to try and perfectly line them up. Okay, so there you go. The hot at the top still, the cold at the bottom, and if you look very closely, there's a little merging in this maroon colour in the middle, and that's, you could use this to represent sort of a haze. If there's a lot of impurities in the air, so if there's a lot of pollution, then sometimes the convection current can't happen, so you get this sort of layer of haze in industrial areas. But that's another thought which will be more detailed on the website. But the idea is convection currents is what you would use this for. Oh god, that's very closely off. Okay, so hot things rise, so hot fluids rise really, so we should say, so hot liquids rise or hot gases rise. That's the way hot air balloons work. They heat the air inside the balloon to make it, and then it will rise. The reason behind why hot things rise is the particles are expanding out so they're less dense, and less dense things float basically. Okay, so the conclusion is hot things rise because the particles are spreading out and less dense. Cold things contract slightly and so are more dense and will sink. That's how convection currents work. That's why radiators will be at the side of a room, the hot air rises, and then you'll have cold air sweeping along the floor. We'll put a diagram of that on the website to show you what I mean. This is a good experiment, so try it at home and a friend's home and at school in any way you want, but try it at a friend's home mainly, same as other people learn about the science. Like, share, subscribe, all the usual stuff, and then you've got to check out our Facebook, Twitter, Patreon, Google+, and our website where this will be written up in slightly more detail, as well as a couple of diagrams showing you where it would work in practice. Hopefully it won't be as long until our next episode. See you next time.